production rate that you want to have. this little guy right here is indicating what happened to the rest of the aquifer, that cone of depression around the pumping well has lowered that static water level around in the nearby areas. One of the things that is a big deal when you do a pump test for long-term usage wells, that you don't want to impact the adjoining wells, and that may cause an issue of reducing their capacity. Huh, that must be the end of my 2 bits worth. Have I confused everybody?
When you first put in say a typical domestic well, and a lot of times I've noticed you put in like 5 feet of screen. Are we talking development time usually a couple hours, an hour on something like that?
The department rules say I have to do a development for at least 1 hour on any well. Typically on a domestic well screen, an hour is typically enough to get the fines to get through the screen and leave the bigger material on the outside.
And you're looking to see clean water?
Yes.
Visually.
Again, rules are that a well will be put sand-free, and they determine sand-free, and I don't remember the X number of parts sand per bazillion gallons of water. The same is true for us for a irrigation well, that we might run a development of 4 or 5 hours. We got 10 feet of screen, 30 slot screen. We might run 4 or 5 hours to get rid of all the really, really fine stuff. And again, it's important for you guys as irrigators. You don't want sand coming into your piping and plugging up your nozzles and sprinklers. So one of the issues is, how do I determine where to drill the well? For me, I go look at, you tell me where the property is, I'll go look at the well logs for the immediate vicinity, look at depths, formation, well production, what's there. Ultimately, you, the customer, say right there's where I want it. And my answer is, one of the criteria for me is how close, for irrigation wells in particular, how close are you to power? How close to the point of use is it for you? And is this a spot that I can deal with from a standpoint of getting machinery in and all that kind of stuff? Those are the kind of the issues that I've got. That if the formation, the well logs in the immediate vicinity indicate that their chances of you getting the kind of production you're looking for is not good, I'm going to tell you that. Ultimately, if you tell me there's the spot, I think it's not a dumb idea. If I think it's a dumb idea, I'll tell you it's a dumb idea. And if the bottom line, if you continue to say, that's where I want it, that's where we're going to do it, and we're going to do our very best. How deep do I go? I'm going to go deep enough into a formation to accomplish the well production you're looking for in total gallons per minute, or the bottom of the formation. Hit a layer where there's water-bearing material. I'm going to go down to a point where that formation ceases to exist, set a screen, and see what that's going to do. Unless there's other overriding criteria that says if I go another 150 feet, I'll get another aquifer that may be better. Again, that's one of those conversations we would have before I continued.
When it comes to locating the wells, can you talk a little bit about sanitary control areas and the difference between like a drinking water well versus an irrigation well?
Yeah, drinking water well, I gotta be 50 feet from the septic tank and 100 feet from the drain field. That's cast in stone. For an irrigation well, setbacks are not an issue from a standpoint of sanitary. Now, obviously, I'm not going to put one next to a drain field or septic tank if I can avoid it. It's just dumb to ever potentially impact the potability of that irrigation well because it may be used for something of that nature in the future. Don't want to make it so it's not possible. Again, the real issue is what's the ultimate use of the well and where is the best location for you, the customer.
If it's a single-family domestic well, how close to the house?
5 feet from a structure from a domestic well. And again, that's county reg. Department of Ecology doesn't care. They absolutely don't care as long as the well is inside your property. And they probably don't even care about that. But the local rules are 5 feet from structure. Again, 50 feet from a septic tank, 100 feet from the drain field, 50 feet from a tight line sewer line. That's gotten him in trouble a couple of times. Domestic wells are pretty straightforward. That, again, where's the point of use and somewhere close to the structure itself, where you're going to build a house, put it someplace that I can get to the well in the middle of the winter when raining cats and dogs and I don't have to go across your shrubbery or those sorts of things to change a pump. And those are all considerations. Again, same kind of consideration you would want to have for an irrigation well that when the pump dies, you want us to be able to get to it to change that pump out. Mark.
Bill, is there a restriction on the size of casing, well casing for a domestic well?
Well, no, there's no restriction. I can drill a 10-inch well. If you come to me and tell me I want a 10-inch domestic well, that's what I'm going to drill you. If you tell me it's a domestic well, that's what's going to be on the well log. It's a domestic well. The restriction is on most well diameters is what size pump you're going to put in this thing. I can get 100 gallons a minute out of a 6-inch well, but if it's over 100 feet deep, I can't move 100 gallons a minute out of a 6-inch well with the pumps that are fit in a 6-inch well. So that drives you into going to an 8-inch well, that kind of depth, that kind of gallonage. And the real issue is on well diameter is how big a pump is going to go in the well. And that's driven by the ultimate production rate that you're looking for.
One more question. Oftentimes we're looking at well logs when we see a well capacity.
Mm-hmm.
And I was just hoping you could explain the difference between the pump down test and that well capacity on the well log.
Well, typically the well capacity on a well log, I'm using an airlift. And a domestic well, 10, 15 gallon a minute well, I can use the old 5-gallon bucket and a stopwatch. We're getting to the 200 gallon a minute well. I'm checking that out of the discharge of my drilling machine using airlift, 55-gallon barrel underneath the discharge. If the discharge is down low, if it's up there 15 feet in the air, it's really tricky to do that with, again, a 55-gallon drum and a stopwatch, and you get really wet when you're trying to do that. And that gallonage is pretty suspect. A lot of those gallonages I see out of a discharge it's my eyeball and my guess what that looks like. And what reality, if you really want to know, you really need to do a pump test.
You guys can do a pump down test.
Yes, we have to put a pump in the well, put a probe in the well when we run the pump to see where the water level actually is. All of those things, that kind of diagram would be what we would do.
So oftentimes we'll find a situation where there's a new well, the well log says it does 300 gallons a minute, the size in the pump is 300 gallons a minute. But what you're saying is that 300 gallons a minute is an eyeball estimate.
Yes, and very honestly, that's a very difficult thing to do with strictly an air discharge out of the machine. If you got a 6-inch piece of pipe and discharge, and you got a slug of water coming out, and so very much so. And anybody that absolutely relies on that as being fact. It is a fact that it's our best guess. I wish I could do different than that, but there isn't any neat way of doing it. Again, I can get fairly close if I can get the discharge low enough on the machine and put a 55-gallon drum, and I can get closer. It's still a best guess.
I'll interject one thing into that too. When you're for an irrigation well, you're interested in using it day after day after day, sometimes for long periods of time. You know, the little tests that Bill would do once the well got in, doesn't really tell you how it's going to perform over a long period of time.
Right.
It's not going to tell you what the recovery is.
Yeah.
One of the other things we found too is that even, you know, Bill will go in and he'll drill a well in a bedrock situation when we've got traction systems, and he'll do a 4-hour test and produce, you know, reasonable quantity of water. And then basically Bill wraps up and goes away. And somebody else comes in for domestic use, they're going to have a lot of water that they need. But it's really critical, particularly in those bedrock aquifers, is how does that water get recovered? Because if you just in 4 hours it produced 5 GPM, but it basically dewatered the formation in the well, and it takes 6 days to recover, you've got a problem. You're going to put a house.
Yeah, I've done one of those on off of can't remember the name of the road. It's off of like Padden area. That the well initially was doing 15 gallons a minute. I was suspicious of it, so I pumped it and came back 4 hours later. It pumped down. Came back the next day. It only pumped about 5 gallons a minute. The third day it was down to a gallon a minute, and it took a week for it to come back to its original static level. The rock formation wells on long period draws get really, really squirrely. You can almost bet that the production rate is going to be significantly smaller over time. And that's one of the reasons you want to do a long pump test, even on an irrigation well, is yes, I can get 200 gallons a minute out of it today, but if you run 200 gallons a minute out for a week, it may not do that. And that has to do with guys like Chuck, who can tell you the formation is big enough that it shouldn't be a problem. But there are some places where the actual recharge to that particular pocket of gravel that I put my screen in is a pocket of gravel that recharge is a mile away. It's pinched off, that you drain the immediate vicinity. That's what a pump test does, is basically dewaters the immediate vicinity.
So I know there's at least a half dozen of you in here that have struggled with some of your wells. So it's pretty different to have vegetables going deeper, going bigger, going fatter, going better.
Yeah, well,
I know from experience that
On that, if I need more water, is it better for me to have you come out and I keep drilling, or is it better for me to speak to kind of storage system? Like I know I have a drip system, I know how much water I'm going to need, or is it better just to have you come out and I keep going deep and I get more water?
well, that's a dilemma I'm constantly faced with, because a lot of times I hit the bottom of the formation. That's all there is. And the next stop is 500 feet. So from an irrigation standpoint, if you get 100 gallons a minute and have 3 zones versus 200 gallons a minute and only have 1, but if I can't make that happen, I'm not a magician as much as I'd like to be, but going deeper is always an option, but that's a decision that should be made when you're drilling the well. If there's any issue of whether they got enough water coming out of the borehole we got, we should continue on until we're just absolutely sure you're seeing 100 gallons a minute and you want to have 100 gallons a minute, but it's a little dicey. Better go another 20 feet and put more screen in the well to make sure that the aquifer is going to support what you want to have done. Bigger diameter well isn't necessarily any real improvement. You get It's funny thing about screens is a 6-inch screen versus an 8-inch screen. An 8-inch screen have less capacity per foot than a 6-inch screen does, because the 8-inch is made to accommodate a higher external pressure on the screen, so the wire is heavier, and so you get less open area in that screen interval with a 8-inch screen than you do a 6-inch screen, because the crushing capacity on an 8-inch screen is that they have to make it stronger to deal with the bigger diameter. You get about 20% more to go to a 10-inch screen over an 8-inch. And it's not exactly linear, and it just drives me crazy, because I can get, like I said, I can get more capacity out of a 6-inch screen, but I can't give you a well that you can put a pump in that 6-inch screen. It's a matter of physics.
Any other questions? Thanks, Bill.
Okay, thank you. My retirement. Pardon me? A horizontal well, they go out and dewater an area, dig a trench in it, put perforated pipe in it, put pea gravel around the outside of it, put a fabric cover over that pea gravel, and then put the dirt back on and let the aquifer recover. It's not much different than a sand-packed well, but it allows them to get a huge amount of area that they're able to draw from. Typically, you run underneath the berry field and put the berries back over the top of it, and use the irrigation. They're irrigating anyway, so a certain amount of that water winds up going back to recharge what they're already taking out. It's an excellent application for the linden flats out there. Department of Ecology is driven crazy by that one. They don't understand how to describe it. It's not really a well by their definition, even though we put a vertical column at the end of the horizontal part and treated it as though it's a well by putting a surface seal around the vertical column and all that. But there are no real rules about horizontal wells. Great application.
Thanks, Bill.
You're welcome.